All right, good afternoon, everybody. Thanks for jumping on with us. It's 12 o'clock. So far, we've got a lot of people signed on. I'm going to give it maybe another 30 seconds just to make sure that all the other attendees get on. I know, everyone's just getting to lunch right now, maybe finishing up a couple of things that they're working on. So, like I said, let's give it another 30 seconds or so, and then we'll jump right into it. So, thanks everyone for jumping on, and hang tight. All right, I think that's enough time. So, like I said, let's jump right into it.
What's up?
I gotta mute you because you got a little feedback. All right, that should take care of the feedback. All right, sorry everybody. All right, so let's jump right into it. Thank you everybody for jumping on. My name is Greg Rathe, and we're doing a little Rathe review, a little online webinar series because right now it's obviously very challenging for any of us to get together. So thank you all for jumping on. This is a lunch and learn. You guys probably all saw on the little flyer that we sent out that this is as a lunch and learn, we want to offer lunch to you guys. Now, unfortunately, we can't do it directly in person as we normally would, but I guess in its place, we're going to be sending out everyone who attends a Grubhub coupon. So unfortunately, we can't have lunch together, and unfortunately, we can't have the lunch even today, but the coupon, we will get that out as soon as possible to everyone who attended. So already thank you everybody for jumping on. Couple housekeeping notes before we get into it. You guys have probably all been on these webinars before. And by the way, anyone who can, it would definitely be helpful to make sure everyone can hear me. Just type something into the question bar just to make sure that everyone can hear me. But I think we've gotten pretty used to this now. It should be all right. Anyone who's not familiar, the question bar you see is right up to the top there. That's where you would type something in. I see someone wrote something, so thank you. We don't have any handouts this time around, so you could just disregard that. But Rich will be doing the presentation, and any questions you have, just type them right in there, and we will address them towards the end. If anything is good, or if anything is worthwhile, that I'll just jump in the middle of Rich's presentation and make any kind of announcements that I have to. All right, anything that we can't get to on the webinar, please feel free to reach out to any of us on the Rathe Commercial Development team. We've got a great team of guys, and we're really here to just help you see that project through from beginning right through to the end. And this presentation also will be posted on YouTube. We've got a growing archive of information, everything from these webinar presentations to more technical things. And during this COVID pandemic, we've been pretty busy adding a lot of new content and a lot of new things that we could really provide to make your experience with Rathe Associates better and better. One of the most exciting things that we have is this Connect Direct tool. This is a real-time video technical support feature that allows, if you are on site, whether you're an engineer, a contractor, or something in between, we can do a video support with you. It's a lot better than FaceTime or a lot of these other apps, because there's no app necessary. We'll send you a link, and just like that, within the click of a button, we will be video chatting. And it's an amazing tool. Everyone loves it. Everyone here loves it as well. Everything just moves much quicker. We've also incorporated a Rathe knowledge base. This is a tool that allows you to quickly look things up. We have a growing list of articles and information that's available that you can quickly type into the search bar that you see on that screen there. You type in anything that you want, and just like Google, it'll start making assumptions based upon the articles that we have written in there. Oh, click it again. No, just click. Nope, click again. All right, a couple extra things. We do have prefabricated skid mounting capabilities available to you. And coming soon, we're going to have our equipment selection software tool as well. It's a great tool that allows you to just plug in a couple values and just immediately give you spit out a list of equipment, schedules, cut sheets, submittal documents, a whole lot of information. All right, and I have to announce this as well. So maybe some of you are aware or may not be aware. A little bit of content here. Won't get too into it, but this is the Rathe Concierge process. This is just really what you've been experiencing with Rathe for the past 51 years, really just explained as a procedure. Every project we get involved, we want to be involved as early in as possible, but at any point that we get involved, we will really take ownership as much as possible. We want to go over ways to value engineer, look for opportunities for other equipment that can improve design. I mean, every project these days is already over budget. So how can we use our brains to improve upon the design or find ways to reach the owner's budgetary confinements? On top of that, we want to be involved with the installers even before the installation. You know, anything we could do to discuss frequent mistakes, things that we've seen hundreds of times. So if we can get ahead of it, that's something we want to be a part of. Of course, we'll go to the job site as much as necessary. We're not going to get crazy arguing with anyone about when we could be there and how often we could be there. If you need us, we'll be there. Just to really help the project move along as smoothly as possible. We do equipment startups, and we'll even do training for the people who are going to be using the equipment at the end of the day. So with that, all that being said, your presenter, it's not going to be me. It's going to be Rich Smith. He's a key member of our commercial development team working with engineers and contractors in our New York market. Rich spends much of his time designing, sizing, and troubleshooting systems, as well as showcasing new technologies and applications to our customers, like what he'll be doing today. With a 20-plus year track record of successful technology integration into automation of both industrial and commercial applications, Rich has brought the same fervor to our new challenges in seeking out energy savings and reducing carbon footprint to every system that we review. So with that being said, let me pass it off to Rich and let me unmute him.
Hello, everybody, and welcome today to the Rathe Associates Energy and Technology Solutions. The reason why we put this together is obvious because we're all up against that local law 97 and 87, as well as our 2035 and 2050 zero carbon emissions things coming up in the future. So we figured let's get involved early on, look at all the technologies available, and see where we may be able to design and implement newer technologies to help to recapture some of that carbon footprint and eliminate some of the waste that we have in our designs right up front. So new pumping technologies all designers should know about. This is a design envelope with Armstrong pumps. And basically with our pumping technology today, we have traditional pumping systems, which are no data on the system, no corrective actions, pressure sensors with installation problems, drift, and reliability, also excessive redundancy, oversized pumps and motors, and then wall-mounted VFDs. Very expensive installations, and oftentimes we don't get those pressure sensors in the right locations, right? So then also compare that to a design envelope solution. So we'll connect to the cloud for optimization with machine learning. It's a sensorless pump control. It has the appropriate amount of redundancy using parallel pumping and reducing equipment and installation costs. So your first costs are actually reduced right up front. Let's take a look at the sensorless pump control. So Armstrong sensorless pump technology is a control logic that simulates a single zone differential pressure sensor operation. All of the logic is embedded on the control. There's no external sensors, no wiring installation, location, setting of ranges. There's also no calibration, drift, or issues that come up with valves and things like that that we don't know about. it's pre-programmed and mapped at and tested, certified tested at the factory. So there's no custom programming required by a controls contractor. Big plus. That's up to a $2,000 savings just based on eliminating the cost of a sensor installation. So now the control with a sensorless versus a sensored system, basically with the sensor upstream, the changes in the system are read by a differential pressure sensor, and it converts the signal to 4 to 20 milliamps. The VFD reads that signal and will modulate the speed. A sensorless control actually senses the changes in the system by a motor amp draw change. The design envelope pump compares the amp draw to its programming map, which was predetermined, that's up here from the factory, and then it slows down or speeds up based on the programming map to optimize the efficiency and maintain the head level of your system, which will in turn give you higher efficiency. So now we integrate parallel pumping systems and redundancy. So the background on HVAC pumping is basically we would have one pump operating at a time, and we have a standby pump 100% flow in redundancy in the event of failure or maintenance. So we'd have the swing lever and we'd just crank up the second pump. What we found is that that's not exactly the best way to go about it when we're dealing with our carbon footprint issues, and I'll show you why. So why do we use a parallel pumping system? HVAC pumps are usually operating at part load, so we can select multiple smaller pumps to handle that load. And if one pump fails, we'll still have sufficient redundancy for the remaining pumps to handle that load. So unlike other equipment, a pump system redundancy is not directly determined by the number of pumps. So we can reduce capital cost, reduce the energy cost, and reduce the footprint, the physical footprint in the space. So right here, this is your traditional system. You have the VFDs mounted on the wall or a stand. You have the differential pressure sensor, and then the two systems mounted on floor mounts with concrete pads and isolation, vibration isolation for each system. Here's your vertical inline pump with integrated controls. So right here, you'll see the VFDs have moved onto the side of the motor, which definitely helps save on some space, and layout definitely will give you a lot of savings on the electrician, because he comes and he hooks up power to this system and then walks away. But then we have this other thing, which is called a Tango or dual pump with integrated controls. So everything is integrated on the one system, and the redundancy is built in right into the same discharge and suction connection. So you have one set of connections in this particular case. So the cost and carbon footprint sizing for 100% standby versus a 2 by 50 in parallel, what you'll see is on the left-hand side, we have two 20 horsepower motors, and on the right-hand side, we have two 10 horsepower motors. They both have the same output capability, but the upfront cost of setting up two 20 horsepower motors in the amperage and how much current and what type of wire and everything you need to and from those pumps is a tremendous change. Also, as you notice, the size, just the overall size is just so much better. So here's a little study here, duty versus standby comparison, your first cost. So based on horizontal end suction pumps, you'll have 2 by 100 20 horsepower motors, and the Tango is once again the 2 at 50%, which is 10 horsepower. The total pump weight right off the bat, 1,200 pounds for the horizontal end suctions. The Tango is 200. That's a tremendous 83% savings in weight. The installation weight, which is the concrete pads and all the extra piping necessary to have individual pumps, 2,800 pounds. The Tango with the single hookup, 710. once again, huge savings. The footprint though, this is shocking, 28 square foot versus 5 square foot. So I know in most of our applications, even in the retrofit applications, where we may have had 2 pumps, we don't have the room anymore because you know what, the cooling towers get bigger, the other controls have taken up square footage in the space. So we really need a solution that will take up, 82% less than what's currently in there. And then once again, the cost of installation, 2 pumps versus the 1 pump solution or the 1 pump Tango is substantially less, at 2,600 versus 74. So the engineering behind this is based on the capacity split effect on the redundancy. So when you have intelligent controls, and the single pump curve on a Tango will land us here on the system curve. 100% design, you'll be all the way out here on the gray spot. But generally, we have an extra buffer of flow available from that pump if we speed it up a little, and we'll get 70% of the design flow out of a Tango if one of the motors fails. So instead of an actual 50% split, we'll have a 70% flow redundancy, and that's based obviously on the pump curve. So for a 2 pump system, 2 by 50 capacity split, you'll get a 70% redundancy. And look at the heat transfer. We get 90% heat transfer on that 70% flow rate. So you have to be asking yourself, how is this possible? Well, hydronics is a very forgiving technology, obviously. And the flow and the heat transfer are not a one-to-one relationship. So now also when we bump up our capacity to 70%, so that's by enlarging the Tango to the next size, we'll get an 85% flow redundancy per pump, and that gives us 95% of heat transfer. And I'm sure we've designed way more than 5% excess capacity into our system. So we're already probably over 100% of what we actually need. And in a part load, we generally need a lot less. So, and then of course, 2 by 100, you're always going to have 100% flow and 100% heat transfer. So no change there. So this I thought was very interesting because the conversation comes up. I have mission critical applications, and a lot of times engineers don't understand that, some mission critical is more mission critical than others. From the design standpoint, your generic duty, which would be your schools, apartments, condos, and religious institutions, a 20 by 50 split is more than adequate with the 70% flow redundancy. In a high comfort, like maybe a very high-end hotel or offices or commercial and mixed uses, like your universities and college campuses, we need to bump that up to a 70% split. So we're still going to be saving a lot of energy, but we're rising our flow rates up, so that way we're able to accommodate the quick changes in temperatures that are necessary in these spaces. And then of course your mission critical, which is your critical care facilities, hospitals, blood banks, R&D labs, and don't forget data centers where we keep all our computers. We'll keep those at 2 at 100% split, but we still have an option for you for savings as well with the dual arm selections. So the parallel sensorless control, pump control, Armstrong, we refer to as PSPC, it'll control from 2 to 4 pumps for best efficiency operation. It's different than what we generally design into a VFD. The logic embedded into the control, there's no PLC once again, no differential pressure because we're using design envelope, and it's pre-programmed and mapped and tested at the factory once again. So let's take a look and see on a chart. Now this is an active chart. It's not very quick, but I'll show you real quick here. On the top, we have 3 individual pumps that are built into a design envelope for efficiency staging. And down below, we have 3 pumps based on speed staging. Speed staging will increase, and you'll see that we cross a point here between the first and second pump. This is where the second pump will initiate start for the best efficiency staging. But the lower section, you'll see it's going to continue because you still have this much speed to take up out of that motor. And right now, you'll see that the percentage of power, this is where we want to pay attention. The curve is identical. And now we're going to click along, and you'll see the lower unit is actually increasing in power requirement, while the upper system is maintaining the same level of power while bringing the second pump online. That's amazing. We have the same result, but one of them is about 30% of total power capacity available for the pumps, and the other one is still around 18 to 20%. As we continue on in the speed versus efficiency staging, we'll come up to the next point where you can see now we've risen up to 40%, and we continue to go down the speed curve, and we're all the way out at 80% of that curve. The Armstrong pump has brought on the third pump already because it was more efficient to add the third pump into the mix than it was to maintain just two pumps operating. And as you'll see right now, as we continue to go to the following or the total flow that we designed for 100% maximum, here the power ends up coming out to the same, but we know that we work in part load most of the time, so the savings is right there in the evidence on the flow curves. So the performance benefits, you'll see here the speed staging. If you had 3 40 horsepower pumps involved here, your operating costs would be about $30,000 on speed-based staging. On best efficiency staging, you would have to be at around 20,000. So that's a 34% savings. That's substantial, and not to mention the carbon footprint, how many carbon dollars you're going to be wasting, tons of carbon. So now we move on to higher operating speeds and permanent magnet motors. So in order to gain more efficiency out of these pumps, we need to change the way we do things. So by lowering the size of the motor, we were able to bring in 2-pole higher speed motors based on the new performance technology. So the industry preference traditionally has always been the 1800 RPM 4-pole motors. They're not as noisy, the vibration was pretty decent, and relatively good reliability compared to 3600 2-pole motors from 30 years ago. But today we have a part load, so a lot of times you're running that 1800 RPM pump at about 300 to 700 RPMs, and your power curve is way off the map as far as how much power is going into that motor to put out a relatively low output. So for an example, a 3600 RPM motor in a variable flow application could be spending most of its time at part load or 1800. So now today's technology, it's not just what we're dealing with. Efficiency is king, right? So motor manufacturers have improved the 2-pole designs for increased reliability. All our industries have adopted higher speed motors through innovation. Tesla, for example, runs its motors at 1300 RPM, and I'm sure you'd agree that Tesla snuck up on you every once in a while, and you're shocked to see it there because you didn't even hear it. You might have heard a little tire noise. That's about it. Those motors are extremely quiet. Danfoss has a turbo core compressor that runs at 4800 RPM. So, and of course, other pump manufacturers have introduced higher speed, but the new high speed designs are very quiet. The benefits are we're going to increase the pump efficiency for lowest operation costs, lower the footprint because a smaller motor is smaller, of course. So here's the an example of what a permanent magnet motor design from Armstrong looks like. We have the nice touch screen on it. It meets the IE5 European standards which is 30% more efficient than a NEMA Premium. So NEMA Premium was viewed as the gold standard here in America. It just got trounced by IE5. The efficiency improvement also with permanent magnets is 3 to 12% at full load over an induction motor, and I'll show you how that's possible. And there's substantial weight reduction and physical size, and that's based on the physical design of the motor. So generally we have, we're looking at a cutaway of a motor here, and all of you guys that took electrical engineering for mechanical engineers or whatever, or you might have taken a motor class, the stator core has steel laminations and windings, right? And the copper side, you'll have a steel shaft and a rotor. In a permanent magnet motor, the motor construction uses magnets to generate a magnetic flux, and we eliminate the windings. So these magnets are substantially lighter weight than the copper windings that are necessary in a four-pole design. So right there, you'll see the rotor of aluminum and copper, and that whole section is now magnetic. So the efficiency is really where it matters here, because you saw that 2 to 13% efficiency. As the speed drops off, there's actually a higher efficiency between the ECM type motor and a NEMA Premium. You can see the efficiency right there. And as the speed actually drops, you'll see the efficiency drop on all designs of motors, but you actually get a higher output per on the ECM motor, permanent magnet motor, than you would on a NEMA Premium at lower speeds. Weight, oh wow, here's a big difference. A 5 horsepower induction motor with a controller built in, 150 pounds for a 5 horsepower motor versus a 40-pound total design on the motor and controller with permanent magnet motors. So right there, somebody's back just got saved. So also permanent magnet motors, they generate what they call higher magnetic flux density than the induction motors. What that means is that you have less material, less heat, and lower losses with less noise and vibration. Overall, the whole system becomes lighter. There's higher stable operating speeds, which enable smaller pumps and lower installed costs. They're synchronous, and this is where the trick is. They're synchronous, so there's no slip loss. So our general 3600 RPM or 1800 RPM motors don't really operate at that speed. They're usually at 3450 or 1760. These motors are actually running at 3600 RPM, which means you get the head and the power efficiency right off the bat. Now somebody said, oh geez, but Rich, those two-pole motors, they're so darn noisy. Well, you know, back in the day, oh, what happened there? Back in the day, the two-pole motor 3600, you're right, a 5 horsepower motor would have been 82 dBs compared to an 1800, which was 68 decibels. Well, today's 3600 permanent magnet motor is coming in at 69 dBs. I challenge anyone to be able to differentiate between a 68 dB and a 69 dB motor in a boiler room. It's not going to happen. They're basically the same noise ratio. And then basically on our design envelope pumps that are currently available, we'll go from 1 to 10 horsepower. So we're covering a nice range, and keep in mind that 2 10 horsepower motors replace a single 20 horsepower motor of yesteryear. So the flow range and the capabilities of these units are highly effective. So they're available in Tango style, vertical inlines, and end suctions as well. And this is a cute little add-on. It integrates your spring isolators right into the design of the pump. So what an awesome design that Armstrong came up with on that one. So why do we use it? We use sensorless control to save installation costs versus our sensor systems. No more putting a sensor in the wrong spot or having an enormous run of wire just to have a slow reacting system. It'll reduce the capital and operating costs by having the appropriate flow redundancy for the building. Parallel pumping systems will run in a best efficiency staging, and you'll have lower electrical ratings with a lot less weight. And the benefit from the cost and operation savings of pump speeds greater than 1800 as well, 1800 RPMs. So Rathe Associates has signed up with a company called Sensorless, and Sensorless is a home automation company that has controls for hydronics and steam and a few other areas in your designs. I know it's showing a house right now. It's really just to show you the breadth of all the products available from them. They're available wired and wireless, and can be controlled by a smartphone or computer to help with automations. So primarily our interest is in the hydronic and steam area. And currently there's a problem in a lot of our buildings where it's very hard to control the temperature from a radiator. And users will generally, or your tenants will generally just open windows to regulate temperature, which is horrible. It's not energy efficient at all. Steam systems have the same exact problem. So what Sensorless has come out with is a kit where we integrate a wireless thermostat and a wireless battery operated actuator and window sensors to all work together to control the system flow through the radiators, and based on comfort, not just based on pressure as some systems run right now. Also, the battery operated thermostat can be placed on an interior wall, which gives you a much better measurement of comfort in the space, and it will shut down the flow of heating water generated through the radiators, and allow that water to be, or allow that energy to be recaptured and sent to other areas that may need it, which will in turn give you an efficiency. Also, we have window sensors, which will close the radiators down to 10 to 15%, so you don't have a damaged system based on this, but it will make the space cooler, and hopefully they'll close their windows and comply with the rules. So our solution can be a 24-volt AC or battery as well, and these are also all done through Zigbee. So Zigbee is the wireless technology that we use, and once again, it's a battery operated thermostat. We also have a 24-volt relay, which is wireless as far as communication, and it can control an actuator that's installed in the hydronics. So some Sensorless projects we have going on right now: Yeshiva University and East Midtown Plaza. Those are a couple of projects that are ongoing. And we have a little example of a layout here. So you'd have a large bedroom with a thermostat and a couple of smart relays, or two actuators and a smart relay. And those all work together. A small bedroom would also have the same kind of setup, but with only one smart relay. A living room, you can have this one thermostat control multiple radiators. We have 3 radiators in the space, and each one of them has, the relay kit with the actuator. And all radiators will be turned on and off simultaneously in this design, because they're all being controlled by that one thermostat. So our system also has a coordinator, which will help us to manage multiple spaces within the building. So each one of them would be your home heating control right here. You'd have combinations of wireless, wired actuators, and there could be multiple setups throughout the building, all going to one coordinator. This gives us multiple points of control. So as a building manager, now you're able to see each individual apartment and living space and know exactly who the people are that are constantly calling for heat, and who are the ones that maybe are, you know, even keeping their window open. You'll get notifications on all of that. And it's all connected through an app and the internet, which is fully locked down, and you can only access in and out through other Salus products. Not, you can't really hack this stuff. So there's also some call for control of blinds or what's going on with the windows in each space. So during the daytime in the summer, the energy code calls for you to drop down the blinds to take the heat load off the space, and in the winter also close the blinds at night. So this is also integrated right into the Salus platform. And just a little note on the networks. So we hear a lot about Wi-Fi or wireless networks. Basically, we have two different designs that are out there. There's others, but this is really about endpoint devices, or, you know, point of use devices. So we have a star topology, and we also have a mesh. So the star is similar to like you connecting your device to a router, a single point router. And you know, when you move to the left and the right, you see the signal go up and down. Sometimes the internet's fast, sometimes it's slow. It's because you have a single point of connection to the source. With a mesh design, you have multiple connections to the source through multiple passageways. So you can actually use other points on the network to pass through and get your access to the main hub. And the benefit of this is it gives you a level of redundancy of signal. It gives you a level of healing. So if there is a device that goes down in the system, everything keeps running, everything keeps reporting. It just has multiple pathways to get back. So it's just an excellent overall design while we're looking at these systems. So your benefits are, you know, the cost of a package is relatively inexpensive. They can be configured to fit different kind of room radiator setups. They're very reliable. We have smart relays and also the repeaters available to strengthen a network in a difficult building. And there's really not much maintenance involved. Batteries in a standard kit last 2 seasons. If you want to go with the powered option, that obviously runs forever. And then the gateway can tap into that very powerful control system that can give you all the feedback that you're looking for from the buildings. So be sure to ask us about Salus. Conteca heat metering. So Calefi saw this as the future, and a lot of this has to do with the fact that you have, particularly in a area where you have multiple tenants in a single space, you may want to have a central heating system or cooling system, for that matter, in each space to not have so much hardware cost. And this will give us the opportunity to measure usage based on temperature changes in the system. And the Conteca system is a full heat meter. It controls, or it's able to see flows from a third of a GPM up to 1,000 GPM with the physical flow meter and the temperature taps. And then if you have multiple units of these, there's also a data logger, which everything networks into. So it makes your job easier. You don't have to go to the physical meter itself and record usage of each tenant. In this case, you would actually go back to the data logger and get that information given to you in a nice, neat, and tidy report. So the hookups are real easy. You have the heat calculator, and then you have the temperature supply side and the temperature return side. And then the flow meter also on the flow side with a pump in this mixture. So very simple, very easy. They're being used in a number of applications. I have a mall application I'm working on. And so far the feedback has been tremendous as far as cost per unit and feedback of the system. There's a lot of options out there, but we think the Calefi has definitely got an edge. ERVs. So there are many types of ERVs out there, and I'm sure all of you guys have seen some of these. I always leave this slide up for a second so you can kind of soak in the different types of technologies out there. I'm sure there's others as well, but let's get into it now. So what is an ERV? So it's an energy recovery ventilator, which draws the outside air into a space while recovering as much energy as it's sending it out and transferring it to the air that's replacing it. So there are several types, and you know, there's the wheel, the thermal enthalpy wheel, you know, which is it slowly rotates, it captures energy from intake and exhaust. The sensible and latent heat recovery in this system, and it's a very compact design, obviously, good efficiency. The cons are you're cross-contaminating the air, degrading the wheel material, and that gives it a relatively short life span. Also, as the wheel material degrades, your efficiency does as well. So 68%, 60 to 80% efficiency is the best case scenario on that style. Runaround loop is another old school way of doing it, and there's a lot of moving parts, and there's separate air streams. Positive is there's no cross-contamination because they're completely separate, and but there's a lot of moving parts, so a lot of people don't opt for this style. Then we go into the fixed plate styles, where you can see the warm air from the building and the fresh air supply going through the same space, but never actually touching one another because they're individual spaces through the energy exchanging core. So there are a couple of different styles. We have the single box, and then we have the multi-box units. The multiple road stacked plates actually have small spaces between each layer, so there won't be any cross-contamination. There's very few moving parts. Sensible and latent heat are recovered. The bad thing about it is you're only getting about 50% efficiency. I know they say 50 to 60, but realistically, you're getting 50%. And you know, the more efficiency, meaning you just have to keep on increasing the footprint or units. We rep a company called BPE, which actually takes 5 of these units and puts them in tandem. There's multiple passes in each one in the stack plate, and there's a lot larger spacing, so that way we can have lower pressure drop across it. And also, there's no cross-contamination. We have 90+% thermal efficiency ratings and EER ratings up to 126. So it sounds like a miracle, right? Low static pressure and 20-year expected life cycle with virtually no maintenance other than on the fans. So here's a little closer look. You'll see the 5 cubes in there, and everything's fully aligned and gives you the best flow rate through. And basically, it's just a better design of a decent design to give us the highest efficiency out of this type of system. It can be run as an independent air exchange system because of the efficiency level. The temperature drop is not so great that we need to add any kind of heat or cool to this unit, or it can be integrated into your current HVAC system. So this is basically more of the same thing, virtually no maintenance, plug and play, adjustable, and BMS, we are BMS compatible on these as well. So if you have an application, please give us a call about ERVs. And once again, a little bit more of the expected lifespan, basically all the same stuff. Here's a quick case study though. I wanted you to take a look at this, and it was the Manitoba hydroelectric plant. They were looking to do air exchange, and basically it was either a DOAS type system, or they were going to open a garage door or leave a garage door open all times, or put in one of these systems. So they did a case study, they installed the system, decided to go with ERV style, and their upfront cost was over here, is about $255,000. And but take a look at this over here. when we went through all the calculations and everything else, there was an HVAC cost, avoidance cost of 109,000. What does that mean? That means that the system required to maintain that space was able to be downsized substantially because of the savings applied by this system. So even when we added the 255,000, the overall design of the building was almost $110,000 in savings. So our net capital expenditure is only 145,000. And when we did our calculations, it came back with a 2.61 year payback. So really impressive. And then the last thing that's down here is the emissions reduction. So that's cars per year. That's literally how many cars did we take off the road this year. So it's 133 and a half cars. So that's a tremendous report for the BPE unit. Lars. So, we've been a Lars boiler rep for a long time, and we've always had a lot of great products from them. Let's take a look and see what Lars has been up to this year. So as you can see, we have a couple of projects that have been out there, Neptune and Essex. The Omnitherm. So this is something that I think is going to be very interesting to most of you. What this is the Lars' first near condensing boiler and volume water heater product. It has a 7-to-1 turn down because it has a new oxygen gas train sensor and valve control system built in. Super long life stainless steel heat exchanger built in. It can be category 1 or 3 for low temperature operation. And it's versatile. It can also be 1 through 4 basically as well. But the 7-to-1 does come in at the 2 and 4 category ratings. Lars Link is integrated into this, and we'll get into Lars Link in a little bit. And there's flexible installation. It's a small footprint. It'll fit into most elevators. I have to say that. And it's a very good overall package design. Very nice, neat, and tidy. So if you can look at this right now, you'll see that the electronic air to fuel ratio control is really what's at play here. The peak combustion performance maintains the ideal gas density, and oxygen levels within the air to fuel ratio at times. So these are, GM high performance level sensors that are running here. This isn't your old school boiler type sensors. So high efficiencies at all firing rates. That means that it's being regulated and tested at all of the firing rates in here. So it's a real-time air to fuel ratio. Stable performance, we're looking to have the most stable flame, which gives us the highest output and highest efficiency. Reliable operation, there's no drifting from set points because we've gone digital here. And quick response rate, so it's going to respond very quickly to the air pressure, flow, and density of the gas. So, and then of course, temperature of the systems. So that gives us reduced emissions and reduced operational expenses. These are in the 87% range as far as efficiency. So we have so many new products, I can't spend too much time on that. So we have the Magnatherm high turn down, or 20-to-1 condensing boiler and volume water heater. So everybody's been screaming, we want higher turn down, higher turn down. We weren't ready to do it until we figured out how to do it well. And the top line thing here is the TrueTrack O2 trim is the reason why we were able to do it really well. It's a real-time electronic fuel air ratio control. It controls the full combustion process to give you the optimized efficiency throughout the whole turn down. So if we're turning down at 17% or 17-to-1, it's going to measure everything and recalibrate and give you the highest efficiency and best flame. The Lars Link controller, once again, is involved in this, and this is going to come into play. These are 96% thermally efficient. We have a stainless steel heat exchanger and ultra high output efficiencies. It's multi-stage as well. Very prime pump control, which also helps to maintain the best temperature in your system. And flexible installation, once again, we have a smaller footprint. The cabinet can be knocked down to fit into tight spaces and re-put back together again. And we'll even support this system in 120 volt AC in some cases. So if we have a building that has limited power in it, then we have a solution for you. So let's talk about TrueTrack O2 trim combustion management. So what does it really do? It's going to maintain the oxygen levels to optimize the operation, right? So quickly adjust the counteractive environmental fluctuations throughout the whole range. It increases the runtime availability for, eliminating a lot of the sooting problems we get, and it reduces your maintenance over time. What happens if we don't do this? We'll get an unstable flame formation which will reduce our efficiency. So during the turn down, if we're not trimming everything together, you're going to have fluctuating flame rates. You're going to have increased emissions, less condensing due to lower dew points, because if we lose control of that oxygen, the temperature drops on the dew point. So we need to maintain that as well, and increase maintenance issues, which would be downtime. So O2 track is the way to go. So the Magnatherm FT, so everybody said, why don't you guys make a fire tube boiler? And Lars said, here you go. Here's your advanced fire tube technology. So once again, we didn't feel comfortable stepping into that place until we knew how to control it to the best efficiency. So this also has your TrueTrack trim, but we also have a CF tube technology, CF Tech, which is very good. It increases the efficiency and surface area and extends the life of the heat exchanger. Lars Link is also integrated here, and we have a 95% thermal efficiency. We have superior stainless steel heat exchanger in here as well. And once again, we have a smaller footprint. So let's take a look. These CF tubes are pretty cool. They're like a twisted pinch tube that gives us a lot more surface area on that tube surface, and it makes sure that you have evenly distributed heat throughout the whole flue gas tube. So maximizing the transfer to the water. And flex is a big problem when we have high gas temperatures inside a tube that's surrounded by water. You'll get a lot of thermal cycling going on. So this CF tube design actually incorporates that in the design and allows for more of that cycling. So it extends the life of the heat exchanger by minimizing the stress. TrueTrack O2 combustion is also a big part of this. And once again, it's almost going across the whole line how we're operating on highest efficiency in real world use, not in a laboratory test tube. So the hybrid boiler setup. So this is just a single slide, and it's just to give you an idea. We've been working hard on coming up with something that will give you the best cost and efficiency standards in your building designs. So a lot of times in the dead of winter where we'll get a 20-degree day, you're not going to condense no matter what you do, because you're putting out the highest heat, highest temperatures. You're running that system at the highest rates. Your return temperatures are way too high for condensing. So why not use a combined system or a hybrid boiler plant where you have near condensing product as well as full condensing product? It gives you the best of both worlds. But here's the key that you're probably not thinking. Near condensing products are only about 30% more than a standard efficiency boiler, or 85% mid-efficiency boiler, with all the advanced controls. The Magnatherms, or the high efficiency condensing boilers, are double that price or triple in some cases, depending upon what you're using. So by doing this, you're getting a design that's built for the application, being able to handle condensing, even if the design of the system is to always use the Magnatherms. What a hybrid boiler plant would do, would say, okay, our outdoor temperature is way too cold, and our return temperatures are way too high for condensing. Let me switch the primary over to the near condensing product and let that be the primary secondary boiler, and have the third and fourth boiler be the condensing boilers. That way you're beating up on the non-condensing boilers when you know you're not going to condense. Sounds logical, right? So the tough thing is, how do you control this? Well, with Lars Link and a couple of tricks up our sleeve, we've developed a product, full package that will get you up and running in this way. You'll get the highest efficiency at all of these points. And we're really excited to offer that to you guys, and we're more than willing to help you see how it comes about with our own equipment. So we move on. Lars also has answered the call on the electric side. So with the calls for electrification, we first released this resistive technology boiler. It's up to 1 million BTUs in a 300 kW model. It's a very small footprint. You can drag this thing in and out with a pallet jack, or obviously a forklift. It's 100% efficiency because of the resistant technology, and it can be used emission free because it doesn't have any venting, so no venting requirements. Very quiet operation, you only hear switching going on, and the advanced controls creates a turn down and turn up scenario where it only turns on the amount of heat elements you need for each type of application. As you can see, it's the internals here, very simple design with the switchboard and everything in the front. It has outdoor reset capability and temperature controls, and it can be set up with a 30 or 125 psi pressure relief valve option. And there is an H-stamp. These are H-stamp heat exchangers. So one of the other benefits is that there is a circuit breaker for each element, so you can actually swap these things in and out relatively easily and safely. There's a 120 volt control circuit, so that the controls are very easy, and there's a primary pump relay built right in. So this is really a great product that can be integrated into a BACnet or LawnWorks interface. And we also, you know, in that situation where maybe you've moved over to a VRF or something, and you need something to heat up the space a little bit more than what that can handle, this will actually step right in and do the job with minimal modifications. So the Lars plate, this is our final Lars product. It's a semi-instantaneous double wall plate heat exchanger, very high volume design. So this is for your high-end hotels and high volume, maybe even industrial applications here. It can produce up to 150 GPM, of course, when coupled with a boiler. It has its own recirc and valve clearing technology built right into it. So with a very small footprint, it integrates right in with the building management, either Modbus or BACnet. And all you need is and it has a temperature water control as well. So very well put together product, beautiful package, ready to plug and play. And that's it. Okay, Zigbee is a wireless technology that was developed for the military for communications behind enemy lines. It was basically it's an encoded wave that's run at used to be run at a very low megahertz range, but now it's run up in the higher ranges, so the radios aren't so expensive and don't take that much power. It is still a secure type of design, and the Zigbee wireless is currently being used by all of the security companies for communication of their end devices like window sensors and door sensors and such. Yes, the TRV control actually can be used on a steam system or a water hydronic system. So it's able to be used on either system. It actually attaches to the TRV, and currently Rathe is also offering TRV devices as well. So we can give you a full kit for that. Yes, there is actually currently a couple of versions of that available for you. It's available through your computer, also through your smartphone. And in the case of a multi-tenant building, we can give different level control or viewpoints for each user. So a manager can see things, and if you wanted to give the individual space access as well, you can do that too. So in the design envelope pump system, in a Tango, you would continue to control the other pump, and it would actually speed up to its full speed to make the same flow rate that it was able to, up to 70% of the total design rate. So, and a lot of times we're only running at partial load, so it may only have to ramp up a small amount, and in that case, but let's say we were running at 100% load, it would ramp up and get 70% of the total flow into that system, which would give you that 90% transfer of heat or cool. Well, more efficient than the single cube would be, because there's more surface area in that particular case. More efficient than the other designs. Well, their designs had a limitation on their efficiency from the start, where they'd only have 40 or 50 or 60%. efficiency, so they just would counteract that with adding more cooling or adding more heat to that return air or the fresh air coming in. So the efficiency is built into the stacking performance of multiple cubes, and which helps the outright performance and gives us those high ratings and EERs. So on the individual devices, if we use standard AA batteries, we'll get 2 seasons out of them, not 2 years, but 2 seasons. But there are options currently available on the actuators for the Danfoss valves to go out to an 8 to 10 year type battery. So there's a little bit of flexibility in there for you. So it's not a one size fits all type thing.